Now let's learn about the coagulation or precipitation. Usually colloidal solutions are not stable, and the relationship between the dispersed phase or suspended particles are the dispersion medium, or usually the colloidal solutions are not stable. The relationship between the dispersed phase or suspended particles and the dispersed medium or surrounding fluid is distributed by slight change in reaction or by addition of small amount of electrolytes. Addition of electrolytes to lyophilic colloids, the hydrosol is destroyed and gradually it becomes turbid, and subsequently the surrounding particles aggregate to form a gel or precipitation. This phenomenon is called coagulation or precipitation, and the solid which separates out is known as coagulum. The process varies according to the nature of the colloid and its concentration. The coagulation power differs among electrolytes and depends upon the valency, the electric charge of the ion, and having a charge opposite to that of the colloid. The higher the valency of the active ion, greater is the precipitating action. This is known as Hardy-Schulze rule or coagulation rule. The minimum concentration of an electrolyte which can produce sufficient decrease in the degree of dispersion is called the flocculation value. The mechanism of flocculation or coagulation of lyophobic colloidal solution may be due to neutralization of the protective charge of the colloids by the oppositely charged ions of the electrolytes, and ultimately agglomeration of the colloidal particles. But the main reason for coagulation and precipitation is both dehydration of the colloidal particles by combining with layers of water surrounding them and hydrate shell, and at the same time reducing of the charge of the colloidal particles by the positive and negative ion of the electrolytes. Now, which are the mutual precipitation by combinations between colloids? Many colloids are precipitated by other colloidal solutions. When two colloidal solutions having opposite charges are combined, their electric charges are decreased to the critical value, and flocculation or coagulation or ultimately precipitation occurs, which is known as the mutual coagulation of colloids or mutual precipitation of colloids. This ferric hydrate in the colloidal solution is precipitated by colloidal silicon or colloidal gold, both colloids being thrown out of the solution. So there will be a hydrophobic sol particle, electrolyte is adding, removal of charge will be happening, coagulated sol precipitate will be formed. Then hyophilic sol particle is there, addition of electrolyte will be happening, removal of hydrate shell will be happening, then the removal of the charge will be happening. Hydrate shell, water layer surrounding the particle will be breaking down, like that is going to be removed. Then salting out is happening. Let's learn about the salting out. Emulsoids, lyophilic colloids, are not precipitated by addition of salts in amounts which is sufficient to precipitate suspensoids. In order to precipitate emulsoids, lighter amounts of salts are required to dehydrate the colloid particles and reduce the charge upon the particles by the positive and negative ion of the salt. The precipitation of emulsoids, lyophilic colloids, by adding large amount of soluble salts is known as salting out. Such as the colloidal protein particles in the blood serum is precipitated by large amount of ammonium sulfate, which is outstanding due to its high solubility in water, relatively low temperature, coefficient of solubility. The effectiveness of salting out depends upon the nature of both the cation and anion of the salt. Cations and anions are arranged according to the decreasing salting out powers. This arrangement of cations and anions in series according to their salting power are called lyotropic arrangement or series. A good example of salting out is the mixture of proteins such as serum proteins by different saturations of ammonium sulfate, salting out of solution. Next, salting in. Addition of minute amount of electrolyte ions, especially divalent or multivalent ions in the colloidal solution, increases the stability of the solution, is referred as salting in process. Addition of minute amount of electrolyte ions addition of minute amount of electrolyte ions, especially divalent or multivalent ions in the colloidal solution increases the solubility of the solution is referred as salting in process. Addition of minute amount of electrolyte ions, especially divalent or multivalent ions in the colloidal solution, decrease the stability of the solution is referred to as salting in. Like some ions are absorbed on the colloidal particles to increase the like charges of the particles. Some ions may interact with the surface fluid groups of the colloidal particles to repress the ionization into oppositely ionized group on the colloidal particle surface. As the ionic strength is increased further in the colloidal solution, the mixed proteins, the effective concentration of water is decreased and ultimately a point is reached where protein-protein interaction exceeds the water-protein interaction and now the protein is being salted out. Now let's learn about coagulation. The process occurring in a condensed colloidal system in which the particles with positive and negative electric charge are mutually attracted as it is seen in case of conversion of fibrinogen to fibrin, a less rigid structure. Fibrinogen itself is composed of long fiber-like molecules. The fibrin forms ultramicroscopic crystal-like needles which are deposited and from tenuous interlacing filaments within the source of the proteins, and the immobilization of the molecules in this process is called coagulation. According to the scientists, a profibrin is formed when the electrostatic attraction of its particles, a mesh-like interlacement causes formation of fibrin. Now let's learn about the importance of colloids, biological importance of colloids. Blood clotting and agglutination. When blood is collected in a test tube, it is observed that blood has lost its fluidity and become jelly-like mass after 4 to 5 minutes, which is known as clotting, and it is a colloidal process. Blood clotting is a colloidal process. It is due to conversion of plasma protein fibrinogen, which was in soluble form hydrozole, into an insoluble fibrin hydrogel, stoppage of bleeding, like stepic action. Blood is a colloid solution, and in case of bleeding, it can be arrested by forming clot by application of trivalent aluminum ions of iron or ferric ion or ferric chloride locally, like stoppage of bleeding. Then oxygen carriage. The greater part of O2 taken up by the blood in the lungs is absorbed on the surface of colloidal RBCs and not dissolved in it. Carbon dioxide poisoning. Carbon dioxide gas is a deadly poison to human system because once the RBC absorbs the gas, they cause to carry O2. Globulin of plasma. Globulins are held in solution by protective action of albumin. Calcium phosphate of plasma. It is a colloidal suspension and protected by plasma proteins. Blood is a application of colloid system in biology, and stopping of bleeding. Then oxygen carriage, carbon monoxide poisoning. Carbon monoxide gas is a deadly poison to human systems because once the RBC absorbs the gas, it ceases to carry O2. Globulin of plasma. Globulins are held in solution by protective action of albumin. Calcium phosphate of plasma will be there. Colloidal suspension and protected by plasma proteins. Transport by adsorption. Many electrolytes and organic substances are transported by adsorption of the materials on the surface of plasma proteins. Next is the colloids as blood substitutes. In certain pathological conditions, it is necessary to restore the blood volume to normal, like burn, shock, severe hemorrhages, etc. By transfusion of certain materials as blood substitutes, the following materials are usually employed: whole blood, plasma or serum, solution of colloids like gum, acacia, isinglass, dextran, etc. The solution polyvinyl pyrrolidone, etc. are used as a filling substitute for blood. transfusion of certain materials as blood substitute, solution of crystalloids, saline, glucose solution, etc. The osmotic pressure and viscosity of the solution should closely oppose to the physical properties of plasma. It must be isotonic to the RBC. It must be monoxy and it should be freely available. It should not disturb the process of plasma proteins. Next, cell protoplasm. Cell protoplasm is colloidal in nature. It has a aqueous base or liquid base, fluid matrix or ground substance in which colloidal substances, granules, globules of solid and semi-solid particles, dispersed phase are suspended. Protoplasm is a sol and commonly known as hydrosol and passes readily to gel, hydrogel, and which is reversible, seen in case of pseudopodia. Like movement of pseudopodia in protozoa, macrophages, and phagocytic leukocytes is due to the transformation of protoplasm from gel to sol, reversibly causing increase in volume and fluidity. Cytokinesis and protoplasm. During cytokinesis in a dividing cell, there is flow of protoplasm owing to reversible sol-gel transformation. Plasma, lymph and milk, cytokinesis and protoplasm. During cytokinesis in a dividing cell, there is flow of protoplasm owing to irreversible solid gel to transformation. Plasma, lymph and milk, they are in the colloidal state and usually as emulsoid. Blood is a colloidal solution where the RBCs are suspended. Milk is an aqueous emulsion of fat droplets. The phosphoprotein casein in the milk acts as a stabilizing agent or emulsion of fat in milk. Surface area. Colloidal state of matter possesses greater surface area per unit weight than the matter of mass. The colloidal state of matter also possesses neutralized surface forces to higher degree than the coarse particles of matter in mass. The characteristics is helpful in some process like adsorption of enzyme, substrate reaction, surface tension, etc. Adsorption. Adsorption is one of the characteristic property of colloid. Adsorption is one of the characteristic property of colloid. Various physiological processes show adsorption, such as O2 is adsorbed on the surface of RBC but not dissolved. Enzyme substrate reaction, histological staining with dyes is due to adsorption. Histological staining. Process. Transport of minerals, organic substances by the plasma protein. This is also due to adsorption. Next, imbibition. Probably the movement of cilia is due to imbibition. Since protoplasm is emulsoid or lyophilic colloid, the solutes have a great affinity for the solvent. A large amount of water remains stored in the body by this process. Next is the colloidal osmotic pressure. Water balance between blood and tissue fluids is maintained by the plasma proteins since the protein concentration of plasma is higher and the tissue fluids. The colloidal osmotic pressure of plasma exerts the osmotic pressure of the fluid tissues and difference is about 22 mmHg and is known as the effective osmotic pressure or ongotile pressure. The distribution of fluid between blood and tissue fluids is regulated by the balance between the blood pressure tending to force fluid into tissue fluids and the effective protein osmotic pressure of plasma tending to draw fluid from the tissue fluids into the blood. The albumin fraction of plasma is mainly responsible for most of the effective osmotic pressure because of its high concentration, smaller molecular weight, lowest isoelectric pH, more binding capacity with cations which are held up and are not allowed to diffuse out. This unequal distribution of the diffusible ions due to Donan effect is responsible for about 20% of the osmotic pressure of plasma protein. The albumin fraction of plasma is mainly responsible for most of the effective osmotic pressure because of its high concentration, smaller molecule weight, lowest isoelectric pH, more binding capacity with cations which are held up and are not allowed to diffuse out. This is the Donan effect. This unequal distribution of diffusible ions due to Donan effect is responsible for about 20% of the osmotic pressure of plasma protein. There will be excessive accumulation of water in the tissue spaces called edema or swelling due to pathological condition like nephritis, loss of albumin in urine, liver disease, blood loss. In these cases, either filtration increase or decrease of osmosis decreased due to prolonged persistent evaluation of the filtration pressure, blood pressure in the capillaries, and the reduced protein concentration of blood. Like industrial application and others, we will be learning about smoke precipitation, sewage disposal, purification of water, formation of delta, rubber industry, tanning of leathers, etc. will be industrial application of colloids. Like smoke precipitation, sewage disposal, purification of water, formation of delta, rubber industry, tanning of leather, cleansing of soap, froth flocculation process, chemical warfare, photographic plate like rain, blue color of the sky, tail of comets, milk, soil, etc. are colloids in nature, which can also be stated as an application. So, which are the applications? Industrial applications: smoke precipitation, sewage disposal, purification of water, formation of delta, rubber industry, tanning of leather, cleansing of soap, froth flocculation process, chemical warfare, photographic plate, and rain, blue color of the sky, tail of comets, milk, soil. Now about colloidal ions. Colloids are characterized by the chemical structure of the colloidal molecule and electrical charge carried by the colloidal molecule. The chemical behavior of the colloids is usually determined by the surface phenomena. Hardy studied the behavior of globulins and observed the combinations of both characteristics. 4 states of globulins were identified, like solid condition in solutions such as globulin itself, globulin compound with acid, globulin compound with alkali, globulin compound with neutral salt. Addition of acid or alkali. When acid or alkali is added to the neutral globulin, there is gradual conversion of opaque suspension into a transparent solution. The amount of acid or alkali combined with the globulin cannot be determined. If the solution is dried up, the solid HCl globulin is obtained and is contains salt chloride used for dissolving it, and acid may be regarded as being in true combination. This acid and alkali globulins act as electrolytes because the globulins are electrically charged and take part in transport of electricity. It is present as an ion and charged positively or negatively according to the reaction. But for production of the same solution, the concentration of the alkali must be double that of the acid. Globulin also forms soluble compounds with neutral salts. The charged particles of an acid or alkali globulin may be distinguished as colloidal or pseudo-ions. Colloids have certain properties in common with true solutions. The suspended colloidal particles are distributed homogeneously throughout the water. Colloidal particles like ions or molecules in solution do not settle out. Colloids have shown the following properties, like phospholites. In relation to globulin, to acids and alkalis, it is similar to that of ampholites or amphoteric substance like amino acid. The amino acid can react as a basic anhydride with acids or as an acid with base, thus as a base with acid, and along with that as an acid with base. Amino acids have a zwitterion structure. It can ionize in 2 ways. When both types of ionization occur from the same molecule, an ion carrying both a positive and negative charge is left, and this ions are called zwitterion or dual or bipolar ion. The zwitterion theory can be applied to polypeptide and proteins. Isoelectric point will be there at a certain H ion concentration. This does not carry any charges, known as isoelectric point. From 2 electrolyte, colloids differ in the following aspects. Electrical charge of colloidal particles. Electrical charges. The colloidal particles are not to carry an electric charge almost invariable. The nature of charge of all particles in a particular soul is the same, either positive or negative. Colloidal particles are much larger than ionic or molecular particles, but true electrolyte is smaller. Particles are of varying size conditions in which they exist. According to the conditions in which they exist, an iron has a mass which, the example, is constant. The iron has a mass which is constant. Larger total surface area is required because most reactions occur on the surfaces. Reaction occur at the point of contact or adjoining surface or those compounds carry varying charges of electricity. Always carries the electric charge. Charge depends upon H ion, and in case of true electrolyte does not. An isoelectric point, there is no charge, neutral. But this is not happening in the case of true electrolyte. Because of the identical type of charge present in all the particles of a soul, they repel each other. They carry varying charge of electricity. While ions always carry the same charge, and whether it has a positive and negative charge depends chiefly on pH of the medium, and at certain pH called isoelectric point, thus do not carry any charge and do not move if placed in an electric field, and direction of this movement reveals the nature of the charge. Colloidal ferric hydrate is electropositive and travels to the cathode. The presence of charge is not, however, a necessary condition for stability of colloidal solution, but any agency which will tend to discharge them will often cause precipitation and agglutination. Thus, colloidal ferric hydrate, silica, gold, or boiled albumin are known by the addition of traces of neutral salts, and it is found that in this process they carry with them some of the ion with the opposite charge to that of the colloidal particle. Thus, in the precipitation of the electropositive ferric hydrate, the negative ion of the salt is the determining factor, the coagulating power increasing rapidly with the valency of the acid.